Why does performance even matter? The word performance evokes different ideas in different people's minds. A lot of gamers hear the word performance and immediately think graphics. High-res textures, complex shading models like PBR, and post-processing effects like tone mapping. Performance matters tremendously in these use cases because the GPU and CPU budget of the device is a pretty clear upper bound on the richness of graphics effects that can be achieved. More performance simply means more visual quality. But performance also matters far beyond just trying to achieve the best looking graphics. A great example of this is the difference on our MetaQuest platform between rendering at 72 Hz and 90 Hz. 90 Hz has a whole swath of benefits, most notably providing lower latency and higher comfort to the user. For many of you devs, getting 20% more performance can immediately turn your 72 Hz app into one which is capable of hitting that smooth 90 FPS and getting those associated benefits. Performance also matters in areas like loading time. I think many of us can agree that having your app load in 5 seconds is a lot better than a 25-second app load and will lead to a lot more user delight. Loading time is dependent on a lot of different factors, but CPU cost is the primary one. So any CPU performance improvements that we provide to you can be used to boost loading time. Finally, frame drops, also known as stale frames, are a pretty jarring experience for users. Improving the GPU performance by a certain percentage will often lead to a reduction in frame drops by the same amount if your app is GPU bound. More performance can lead to fewer frame drops and a much smoother experience. So ultimately, even if you think you have no need for rendering these complex graphical worlds, more performance will help your app in a host of ways. But performance is hard. It's one of the single most challenging parts of shipping to our MetaQuest platform. And it's not easy on any platform, but on the MetaQuest, we have a thermally constrained processor in a pretty small area on the user's face. Making matters far worse, the pixel throughput requirements of VR can be extremely heavy in the GPU. Let's go through a few specific differences. Compared to similar apps in other platforms, VR frame rate is typically 72 or 90 Hz, up from 30 or 60 on those platforms. VR also demands a significantly higher resolution, which makes intuitive sense because the rendered pixels cover the user's entire field of vision. And on other 2D screens, the screen is barely a small fraction of the field of view. And oh, by the way, you have to render 2 eyes in VR, not just one, which means almost 2x more GPU cost. So the end result is that the pixel throughput alone can be in the range of 8 times higher in VR than other platforms. And that's why it's no surprise that you, our developers, consistently rate performance as the sheer toughest constraint of building Quest apps. And that's why we're extremely excited to share the massive performance improvements that we've made in the MetaQuest 3. In addition to sharing performance-specific features, we'll also round the talk out by discussing a few things related to visual quality. As a quick intro, I'm Neil Bedecker, a tech lead manager at Meta focused on performance and graphics. And I'm joined by our Qualcomm partner, Rodrigo Rolls-Stutner. Here's a quick breakdown of what we're going to cover in today's presentation. First, we're going to discuss an overview of the compute that we're providing in our new MetaQuest 3. Then, we'll transition into the really exciting topic of how to utilize that additional expanded compute budget, specifically focused on GPU performance. We'll discuss how several of our top developers were able to turbocharge the visual quality of their apps. And finally, I'm going to hand it off to Rodrigo to discuss hardware-specific improvements, as well as some visual quality wins that have been shipped both with the MetaQuest 3 and for our entire Quest line of devices. Let's get started. First is the big one, which is just the CPU, GPU, and memory improvements that our new MetaQuest 3 has to offer. More broadly, these happen to be the performance improvements that the Qualcomm Snapdragon XR2 Gen 2 platform has over its predecessor, the XR2 Gen 1 found on the Quest 2. Now, the GPU is pretty often seen as the single most scarce resource on the device, the one which really blocks your ability to make frame rate on our platform. And this isn't that surprising based on those numbers that we cited earlier about the sheer number of pixels that you have to render in VR. And that is why we're extremely excited to announce a whopping 2.6x faster GPU on the Meta Quest 3 compared to the Quest 2. Now just take a second to absorb the magnitude of that. Many of us, both at Meta and developers alike, view the GPU as that most bounding factor that prevents meeting frame rate on the device. And Quest 3 has 2.6x more graphics processing available via the GPU, all to you, the developer. Now later in the talk, we're going to unpack several specific techniques to utilize that extra GPU, so stay tuned. Next, we'll talk about a very standard processor, which is the CPU. The Meta Quest 3 CPU offers a 33% improvement over the CPU frequencies of the Quest 2 at its launch. And just like the Quest 2, our Quest 3 exposes 3 CPU cores directly to the application. Finally, there's memory. We've expanded your memory budget to 5.75 gigabytes, which is an increase of over 30% from the Quest 2 memory budget. And of course, there's plenty that you can do with that additional memory, like load larger levels with higher res textures. And since memory is a very coveted resource too, we're sure that there's no shortage of ways for you developers to utilize it. So in our perf discussion here, there ultimately is one theme that we really want to drive home, which is that we have been and continue to be working tirelessly in the pursuit of improving the performance of our devices and, most importantly, the perf budget of your apps. And that means that at every single juncture, we're going to do our best to never leave any performance on the table, because every last bit of CPU and GPU that we expose to you is another avatar that you can render, or a faster scene load time, or less motion sickness for users by choosing 90 Hz instead of 72. Now, above all, the Meta Quest 3 is a mixed reality device. So after seeing the greatly expanded performance budget that we just presented, the very next step for many of you devs will be to enable pass-through and other presence platform mixed reality features. When using mixed reality, you will get lower CPU and GPU frequencies than when not using mixed reality. And it makes sense intuitively because when MR is on, the system has a non-zero amount of additional sensor load compared to with MR off. And all of that extra processing will contribute to a much higher MR quality experience for your users. The end result here is that your apps will get 17% lower GPU and 14% lower CPU perf when MR is on, compared to in VR-only mode. Now, beyond these frequency-based differences, there are also a couple more reasons why your performance will be lower when using MR. Rendering pass-through consumes some resources on the GPU on our system's end too. And this means that there will be less available GPU left over for your MR apps to consume. But in a sense, keep in mind that all of that extra GPU is strictly to boost the visual quality of your apps. And finally, there are also some differences based on the feature type that you select. Namely, certain presence platform features like the depth API consume more GPU than apps who don't use the depth API. When factoring in all of these MR perf costs into the equation, your MR apps will have anywhere from 20 to 40% less GPU than VR apps, depending on whatever combination of features that you select. Be sure to check out our documentation online for the full performance breakdown. It's really important to call out that we don't feel that that perf difference is too much of a concern for you MR devs. And there are a few very important reasons why. First, as I mentioned in the last slide, our Quest 3 GPU is 2.6x more powerful than the Quest 2 GPU. So even though you will have 20 to 40% less GPU performance when using MR compared to VR and the Quest 3, that leftover perf budget is still significantly higher when using MR and the Quest 3 compared to the entire Quest 2 GPU budget. And we've seen such a host of incredible graphical titles on our Meta Quest 2 over the years. So if that budget was enough for our devs to produce some great graphics fidelity worlds, then you can be encouraged by knowing that you have even more of a GPU budget in your Quest 3 MR titles. And finally, consider the fact that most MR apps are actually much sparser than what their equivalent VR app would be. The image on the right is a great illustration. It comes from the app Broken Edge when in MR mode. And notice how most of the rendering here only occurs in the middle 30% of the user's field of view. The rest is almost entirely filled with pass-through. Now the VR version of Broken Edge, on the other hand, it renders to every bit of the eye buffers here. And that difference is more than enough for the Broken Edge developers to compensate for the slightly lower GPU performance when in MR mode. So there you have it. Perf maximization for all of our Quest 3 developers has been our primary goal here, and that's why you will have lower perf in your MR apps compared to VR-only mode. But the good news is that your resulting GPU perf budget is still significantly higher than your Quest 2 entire GPU perf budget, and furthermore, the GPU load on MR apps is typically lower than the equivalent load in VR apps. So we're pleased with the current budget and its effect on your future MR titles. Next, we're going to spend some time talking about perhaps the most fun and important topic of how to actually utilize that massive GPU perf improvement that we just outlined. There are no shortage of ways to use the GPU, as many of you can attest to. We'll focus on some use cases that are pretty specific to the context that we put our apps in. Let's first start with render pipeline setup. In some senses, this is funny because for years, we have been encouraging you devs to keep a very simplistic render pipeline, most notably to use single pass forward rendering. In this context, single pass means one main render pass to render all of the objects in your scene without dedicated pre or post passes. And our guidance has been based on the GPU capabilities of the Meta Quest 1 and Quest 2 devices. But with that additional 2.6x perf improvement in the Quest 3's GPU capabilities outlined here, a little bit of our reasoning starts to change. So let's compare the simplistic render pipeline just cited to what you can now do on the expanded GPU budget in the Quest 3. Now, first things first, even though this main pass in this example is much longer than in Quest 2, there's an extremely sizable budget left over. So you probably should increase the cost of your main pass. And now let's start filling the rest in with some more GPU work. Pre-passes can be used for a variety of graphics effects, most notably for effects like shadow mapping or other effects which specifically require a depth pre-pass. Beyond simply filling up the larger GPU budget, another benefit to using such pre-passes is that the new hardware specifically has optimizations that can make such pre-passes more efficient. Rodrigo will cover more details about this when he goes over async binning later in the presentation. And finally, we have post-process passes. Many of you devs have plenty of experience with incorporating such effects as tone mapping, SSAO, bloom, and much more. And for the longest time on our MetaQuest devices, post-processing has been prohibitively expensive for GPU performance. But with that expanded GPU budget here, we truly feel that that's no longer the case. Now, naturally, the GPU cost depends on the exact choice of the effect, and certain algorithms will be a far better choice for our hardware than others. So ultimately, we just want to convey the simple fact that post-processing today on the MetaQuest 3 will be far more feasible now than it has been in the past. And beyond just adding different render passes like pre-post passes, we also want to convey that there are frankly tons of other ways that you can fill the larger GPU budget with. First things first, rendering at a higher resolution iBuffer is always a good choice. We recommend all developers enable our dynamic resolution feature to achieve the benefits, namely for its ability to choose the optimal resolution based on the available GPU headroom on the device. Next, shader quality is also a great mechanism. And if you're a developer who is skewed towards overly simplistic shaders on past MetaQuest devices, as many of us have had to due to the slightly weaker GPUs in the past, one option now on the stronger Quest 3 is to switch to more expensive shading models like PBR. And then there's also texture resolution of your assets. all else equal, higher resolution textures will mean more GPU time is spent during texture sampling, but in many cases, the visual quality win will be substantial of those higher res textures. Better yet, this can also be paired one-to-one with the memory improvements that we cited earlier. Ultimately, there's never going to be a shortage of ways for you devs to consume the extra GPU, and that's why we're extremely excited to see what you come up with. And there's one really important other point when deciding what to spend your extra GPU resources on. For you to even begin to be able to utilize the perf expansion on board the new GPU, you probably need to immerse yourself in our GPU tooling. Your first step can be using OVR Metrics tool to simply see how GPU bound that you are. You'll probably see a far lower GPU utilization number and then go from there. And beyond that, you can get extremely fine-grained data, not just at a per render pass level, but even at a per draw call level, using our tools like Perfetto Render Stage Tracing, OVR GPU Profiler, and finally our Meta Render Dock fork. Now we've arrived at maybe the most exciting topic of all, which is to go through specific case studies of how some of our top developers have utilized the new Quest 3 GPU. We're going to look at 3 different developers and show the ways in which their Quest 3 build outshines their Quest 2 build, and we're going to primarily focus on graphics fidelity right now. Let's start first with Red Matter 2, which is an app who on our platform has long been known for some of the best looking graphics on MetaQuest. The first thing to note here is the shadow improvements that the devs were able to implement. With rendering dynamic shadows for their spotlights, this helped to ground the objects to the scene, and they described this as inching Red Matter 2 closer to graphics parity on all of their supported platforms. They also implemented high-quality PCF 5x5 shadow filtering, helping produce softer shadows, as you can see here, on certain selected surfaces. Next, let's consider the improvements made to sharpness and clarity of the eventual rendered image. The team was able to use 8x anisotropic filtering for all on-screen textures, creating a much sharper image compared to their previous trilinear filtering. And finally, they also utilized the render resolution increase that I mentioned earlier in the talk, and most notably, they enabled our dynamic resolution feature to render 4 times the number of pixels on the Meta Quest 3 compared to the Quest 2. And beyond this, they were able to achieve the exact same texture resolution that Red Matter 2 uses on all of its other supported platforms, which is pretty astounding if you think about it. And achieving that consistency is something that they were only able to do with the dramatically expanded new Meta Quest 3 performance budget. So this increase in texture resolution to reach parity with every other platform that our developers support, it's a theme that we also saw from some other developers in their Quest 3 builds. Vermilion, a popular VR painting app, is extremely dependent on being able to paint and render to a high-quality canvas. They were able to increase the canvas resolution from 1024 by 1024 on Quest 2 to 2048 by 2048 on the Meta Quest 3, now standardizing that canvas resolution to 2048 by 2048 across all of their supported platforms. And the proof is in the pudding. Just look at the massive visual quality difference seen in the painting output on screen. In their developer Thomas Vandenberg's words, it was possible to increase the canvas resolution from 1024 by 1024 in Quest 2 to 2048 by 2048 in Quest 3, the same as on PC VR. This makes for a very noticeable boost in image quality. And finally, we have Population 1, a game known both for its thrilling battle royale mechanics and also for state-of-the-art graphics on MetaQuest. The Population 1 team was able to make a host of changes to their Quest 3 version with the larger GPU budget, most notably being perhaps the choice of 90 Hz, which, as we've mentioned earlier, provides a lower latency experience, which especially matters because their game is a competitive battle royale gameplay. They also were able to increase their resolution of rendering to a whopping 1.44 times our default, which adds an unparalleled level of visual quality. Finally, they were able to set a LOD bias value of only 2 and use 16x anisotropic filtering to boost their texture quality. These examples show the texture differences in pretty extreme detail. So there you have it. Our Meta Quest 3 has a significantly expanded performance budget, with large wins for CPU and memory, but frankly a function win for GPU. And we've seen firsthand how 3 of our best developers were able to boost the visual quality, as well as even latency and the smoothness of their apps with the expanded GPU budget. Now, perhaps the most important theme in all of this is to remember it really is up to you devs to do the same with your content. The ball's in your court now. And now that you've seen the size of the performance win of the new device and the graphics which some of our most talented developers have been able to squeeze out of the new Meta Quest 3, I'm going to hand things off to our Qualcomm colleague to discuss some of the most important parts of the XR2 Gen 2 platform, as well as some visual quality boosting features and tooling that we have shipped together.
Thanks, Neil. Great to be here with all today. My name is Rodrigo Hostratner. I work at Snapdragon Studios at Qualcomm, and I'm delighted to take you all through the innovations we introduced in this new release. Our team at Qualcomm has been working hard, developing the new version of the amazing hardware you are all already familiar with. The Snapdragon XR2 Gen 2 was developed with you, the developer, in Spotlight, and I'm very excited to show what you can expect out of this new platform. We are talking much more than just incremental upgrade from Gen 1 here. Our Gen 2 comes with Adreno 740 GPU, and as previously mentioned, it provides a performance improvement of up to 2.5 times when compared with Adreno 650 from the previous generation. The streaming processor count was double, from 3 to 6, improving parallel processing even more. Double pixel per clock processing from 24 to 48, double texture fetch per clock from 48 to 96 on bilinear, and from 24 to 48 on trilinear. Lots of double here, everyone. The unified cache was increased by 8 times, from 128 to 1024, lowering considerable time spent on accessing the global memory and consequentially lowering overall shader stalls. We also enabled depth and color resolves to be executed separated between each other. If your path signals to the depth isn't being read anymore, it can be resolved into the final render target while the color attachment is still being processed, or vice versa. A few extra highlights worth mentioning here are the up 20% lower peak power consumption, 15% more increase on memory bandwidth, and the large improved thermal dissipation, providing a higher sustained performance over those long VR sessions. We developers sure know how to handle heat in our code, but on our heads, not as much. Now, if you're not in a position to perform any more optimizations and you are still not achieving that smooth frame rates, it might be a good time to consider the Snapdragon Game Super Resolution. It's a VR-optimized, edge-aware scaling and sharpening algorithm designed to maximize image quality. This technique can be used in one of 2 ways. One way is through the usage of the Meta Quest Super Resolution, which was derived from the Snapdragon GSR and is built into the VR compositor, which can easily be enabled for any application. Additionally, the Snapdragon GSR standalone version can still be used for all other surfaces that may need upscaling. For example, render to texture surface, or if the super resolution needs to perform before other passes, such as composition, post-effects, transparency, and others. Now, let's take a look at the advantages of using this technique via the Meta Quest Super Resolution implementation. Typically, the Snapdragon Game Super Resolution would require engine modifications to be enabled, being injected as one of the last processing passes after your geometry is rendered and before any user interface elements draw. With the Meta Quest Super Resolution, it can be transparently added to any application just by enabling a simple layer that tells the VR compositor the intention to use the upscaler. The developer has total control of which layer it should be applied to, and UI elements, if present, can simply be passed via another layer already scaled to size a buffer, not subtracting any flexibility from you, the developer. MetaQuest Super Resolution only requires the application color buffer to perform the upscaling, which eases the integration to VR system and allows it to be applied to any existing applications, without requiring applications to pass any additional buffers. Developers simply need to rebuild their apps to use the compositor layer settings. This process will be described in an upcoming slide. Latency is critical to provide a comfortable and immersive VR experience. This upscaling solution has been carefully optimized for maximum performance while maintaining low power consumption on Snapdragon XR2 head-mounted displays. This is done with a very minimal cost in the composition pass. Unlike other popular super resolution algorithms, we use a single GPU pass, so it can be combined with other operations, avoiding costly additional trips to memory and minimizing quality loss from sampling the image extra times. In this day and age, bilinear interpolation is just not enough to achieve the desired resolution. We strongly recommend using this technique instead of just bumping your eye buffers. It will provide a considerable visual improvement over just stretching your render targets while keeping frame times barely untouched. The upscaler was structured to maximize performance on Quest 3, reaching 100% wave occupancy on Adreno 740. It's worth noting that all these core features listed above are also relevant if you choose to use the Snapdragon GSR standalone. Pairing the super resolution technique with an even more powerful GPU enables you, the developer, to increase the visual fidelity of your games by making use of more post-processing techniques and content, such as post-processing passes. As we all know, these are normally dropped due to their expensive nature, but now you can initially render at a lower resolution, apply all those fancy modifications, screen space reflections, you name it, and only then jump to native resolution. Super resolution can be enabled by setting the quality sharpening flag option in the composition layer extension for OpenXR. In Unity, super resolution can be enabled via OVR overlay for compositor layers or OVR manager for projection layers. In Real, it can be enabled by setting the sharpen filter to quality sharpening on the rendering section. Our commitment on providing support for developers grows stronger. One of the recent tools added to our arsenal is the Adreno Offline Compiler, a fast and efficient solution to extract offline information from your pipelines. Shader profiling and optimizations are essential to increase the visual fidelity of your application or gain that extra frame time to use somewhere else on your pipeline. Without the offline compiler, a typical workflow would require you to query shade information while running your application by using the pipeline executable properties extension of Vulkan or getting a capture to render doc, which not only requires you to have the device available at all times, but also make iterating on changes more complicated and cumbersome. The Adreno Offline Compiler is intended as a portable solution to provide shader information, decoupling the shader from runtime. It can be used standalone with one or multiple shaders, or it can easily be integrated in any project or game engine as an automated tool. It provides a lot of useful information, such as expected register usage, memory footprint, texture fetches, and much more. Having this data in hand when altering shaders or working on materials is crucial to determine the complexity of the final work, giving time back to the developer by shortening iteration times. Sometimes it's just not clear just by looking at your code how well distributed it is between full and half instructions. This can have an immense impact on performance, especially when you don't take consideration all the implicit conversion cases that might happen underneath. Not only that, but it could be overusing registers, splitting to global memory. Maybe texture fetches are not high enough accounted for. Maybe it's a case of low wave occupancy. As you can see, there are many situations you need to take in consideration when designing your pipelines, and the Adreno offline compiler is here to help. One extra bonus is to have the information regarding the generated positional shader. As you all know, the binning path requires its own shader, generated on pipeline creation, that calculates exclusively the positional attribute of your vertices. With the offline compiler, you can get stats from both your vertex shader and also its binning version. Meta recently made a blog post about injecting support on Unreal Engine, which can learn more on their blog post title, How to Improve Unreal Engine Material Shaders with Adreno Offline Compiler, at developer.oculus.com. More information and access to the offline compiler can be found at our Qualcomm Developer Network with many other valuable tools, like the Snapdragon Profiler. Thank you for your time, and if you need any further information, feel free to reach out to me, or for learning more, go to developer.qualcomm.com. Thank you, everyone.